Hey, hello everyone, welcome to my YouTube channel. Today I am going to give the solution for LeetCode problem number 3577. Count the number of computer unlocking permutations. Okay, so in this question, you are given an array complexity of length n. There are unlocked computers in a room with levels from 0 to n minus 1, each with its own unique password. Okay, the password of the computer I has complexity I. Okay, the password for the computer labeled 0 is already decrypted. Decrypted means it is already unlocked, okay, and serves as the root, okay. All other computers must be unlocked using it or another previously unlocked computer following this information, okay. So it says that you have already unlocked labeled 0 computer, means at index 0 the computer is already unlocked. You can unlock or any other computers using this computer or any other previously unlocked computer, okay. You can decrypt the password for the computer I using the password for computer J, where J is any integer less than I with a lower complexity J less than I and complexity J less than complexity of I. Okay, means the computer says that if you want to unlock computer I, then you can unlock this computer I if and only if j is less than I and complexity of j is also less than complexity of I. Okay, to decrypt the password for computer I, you must have already unlocked computer j such that j less than I and complexity of j is also less than complexity of I. Means the computer want to say that means the question want to say that you can decrypt the computer I if and only if the computer j is also unlocked. Okay, so these two conditions must be fulfilled, that uh, if you want to unlock the computer I, then the complexity of j is must be less than complexity of I and j also less than I and computer complexity j is already unlocked. Okay, so what we have to find, we have to find the number of permutations of 0, 1, 2 up to n minus 1 that represent a valid order in which computer can be unlocked. Okay, starting from computer 0 as the only initially unlocked one. Okay, means initially we have only one unlocked computer, that is at index 0. Since the answer may be very large, so return 10 to power 9 plus 7. Okay, note that password for the computer with label 0 is decrypted and not the computer with the first position in the permutation. Means the index, it means the computer at index 0 is already decrypted. We don't have to decrypt it. Okay, it is already decrypted. Okay, I hope you understood. Okay, so currently we have the we have this. Okay, currently we have this example. Okay, now let's understand what this example says, that currently at we have at index 0 and this index 0 computer is already unlocked. Okay, so when the total number of permutations we have to return, that in how many permutation, sorry, how much permutation are possible to unlock all computers. Okay, let's suppose here we have computer 1 and this computer is already unlocked. Okay, this computer is already unlocked. Okay, already unlocked. So we can unlock computer 1 using this this computer, okay, this zeroth computer, we can unlock this computer. Can we? Yes. Why? You can see that let's suppose this is J and this is I. So here J is less than I, okay, and also complexity of J is also less than I, okay, and also we can unlock computer 2 using computer 0 as the complexity of 0 and 2 is also less than complexity of 0 is also less than complexity of 2, so we can unlock this computer also. So this is our first permutation, first arrangement. Now okay, now second arrangement is that we can also unlock, let's suppose this is J and this is 1 and this is 2, okay. This is 2. Now you can see this, that if we can first if we can unlock computer 2 using this computer 0, yes, we can unlock it. Means the position computer 0, at index 0 we can unlock, at index 2 computer we can unlock using the index 0. After this conversion we can unlock firstly we can unlock this 0, this one computer using this 0, because the complexity of this 1 is less than complexity of this 0 computer, okay. After that we can decrypt computer 2 using the computer 1, because the complexity of computer 1 is less than complexity of computer 3. So this is another one possibility. So total number of possibility is 2 is the total number of possibility, okay. Now let's take another example, which is also the example of today's POTT, okay. Let's understand this example also. In this example you will understand the approach for this question, okay. Now look here, if you have this computer 0 and this computer 0 is already unlocked, okay. What we can write here, already unlock, okay, already unlock, okay. इसको थोड़ा सा साइज बड़ा कर देती हूँ इसका मैं, ओके, सो दैट इट लुक्स गुड, ओके. तो ये हमारा ऑलरेडी अनलॉक्ड है, okay. Okay, already unlocked. Now look here, if we want to unlock this computer, and we have to choose the computer from the left side, because J must be less than I, okay. If we are currently at index, this I index, and we have to find the jth index in the left side, okay, okay. But we can see that this 3 is not less than this 3, okay. So what we have to do, we can't unlock this computer, okay. because there is no such computer which is less than 3, and also that computer must be unlocked also, but there is no computer which is less than 3, so unlock की तो बात ही दूर रही. Okay, so we have to return 0 in this case. Okay, I hope you understood. Now let's take modification of this example. Okay, return 0. Okay, now what we have to do, scroll off करो. ओके, यहाँ पे लिखो 0. ओके, नाउ अब हम क्या करेंगे, वही सेम एग्जांपल लेंगे अपना. वही सेम एग्जांपल लेते हैं हम लोग. ठीक है, इसी को यहाँ पे लिखते हैं और इसमें मैं थोड़ा सा मॉडिफिकेशन करती हूँ. क्या मॉडिफिकेशन होने है इसमें देखिए. इसमें क्या करते हैं, इस 3 को हटा देते हैं. इस 3 को नहीं हटाना भाई, पूरा नहीं हटाना है यार, पूरा हटाने लगता है ये. हटाओ, मैं खुद ही लिख लेती हूँ. पूरा हटाने लगता है, पागल हो जाता है ये एडिटर. ठीक है, यहाँ पर मैंने लिया 3, यहाँ पर मैंने लिया 2, फिर मैंने लिया 3, फिर मैंने लिया 4, फिर 4, अगेन 4. ओके, अब देखिए यहाँ पर जो 3 है वो अनलॉक है एट लेवल 0. ओके, दिस इज अनलॉक ऑलरेडी. ओके, नाउ this 0 index computer is unlocked, but it can't unlock this first index computer. Have you see? This can't unlock. It can't unlock this first index computer. Why? Because this computer has low complexity than this 0th computer. Okay, so it can't be unlocked. And if you see that there is no any left. Any computer at left side which can be unlock this computer. Okay, there is no any computer on left side. Okay, so if this computer is not unlocked by the first index computer, sorry, 0th index computer, so it is also not unlocked by any other computer. Why? Because each computer is first unlocked by, means each computer is unlocked by this 0th computer, if and only if this is the minimum value in this whole complexity. Okay, means the complexity, in the complexity array, the minimum value must be at 0th index, then we can only unlock the whole array. Okay, then we can unlock the whole array. Like if 3 is already, if 3 is unlocked, 3 must be unlocked, because the question says that. Okay, so 3 is unlocked. Okay, now if there is an array, if there is a number like 1, sorry, like 4. Okay, like 4 बड़ा लेती हूँ. Okay, like 4, there is a number like 4. Instead of 2 I take 4. Now here 3 can be unlock 4. Sorry, 3 can, this 0 index can be, this 0th computer can be unlock 1. Okay, can unlock 1. Okay, if now it unlock 4. Okay, it unlock first computer. Now this 3 cannot be unlocked by this. Okay, this 4 computer, as this 0th computer, this first index computer is unlocked, but this cannot be unlocked this second computer. Why? Because the complexity of the second computer is less than complexity of 1, but it must be greater than for the unlocked. Okay, now you can see this is unlock computer. Okay, so this is how this computer will be unlocked. This computer is unlocked by the first zeroth computer. Okay, because the zeroth computer has less complexity than the first computer, but this first computer is not the not have the complexity less than the second computer. Okay, so if this computer is not unlocked by this first computer, so how it can be unlocked by the zeroth computer? Okay, it cannot be unlocked by the zeroth computer also. So the main idea is this: the minimum value must be lie on the zeroth index. Then we can only decrypt all the computers. Okay, and less than भी मस्ट बी लेस देन, इक्वल भी नहीं होना चाहिए, इक्वल भी नहीं होना चाहिए, लेस देन होना चाहिए। क्वेश्चन में साफ साफ बोल रखा है इट मस्ट बी लेस देन। ओके, यू कैन टेक अनदर एग्जाम्पल लाइक 2,4, 2,4, 3, 1. Okay, now you can see that this 2 is the zeroth computer and this is already unlocked. Okay, now when we move to this computer, this first computer will be unlocked by the zeroth computer. Why? Because in left side this is the first unlocked computer which have less complexity than this first computer. Okay, this is unlocked. Now we move to another. Now this first computer is unlocked, but it not have the complexity less than the second computer, so it can't be unlocked by this, but it have the complexity less than zeroth computer. Okay, but if it has the complexity greater than the zeroth computer, so it can be decrypted by zeroth computer. Okay, now we move to this computer. Okay, now here this third computer is can be unlocked by this second computer. No, it can't be unlocked because the complexity of the third computer is less than the complexity of second computer. Okay, now we move further left. Now this first computer is also have the greater complexity than the third computer. Okay, now we check on zeroth computer. Zeroth computer is also less complexity than, also have more complexity than third computer. Okay, so we can understand here that if this second computer is already unlocked, okay, and it have more complexity than third computer, then it also more complexity than the zeroth and one and previously left side computers, because this third computer is unlocked by its left side computer, and its left side computer have less complexity than this, but this computer is already have less complexity than this, but it must be the greater complexity. Okay, so this is the idea that in this the complexity array, the minimum value must be lie on the zeroth index, then we can only find the total number of permutations. And the main now the second part of this question is that how we can find the total number of permutations. This is very easy, that how we can find. Let's take an example that let's look here. There is in 3 computer. Okay, 3 computer, and this first computer, this zeroth computer is fixed because this is already unlocked. Okay, so this is fixed, we cannot move it. Okay, because we have to unlock the another computer. So we have to find the permutation to unlock all the computers, remaining n minus 1 computers. So if this is fixed, then if we fixed this also, if we fix this also, then how then remaining computer is, if this fix also, then remaining computer is n minus 1. If we also fix this, then remaining computer is n minus 2, n minus 2, dot 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 dot, एक मिनट अच्छे से बनाओ, डॉट 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 dot dot dot, like here this is 1. Okay, means if we, this is already fixed, if we fix this computer is also, then total number of permutation is n minus 1, remaining is n minus 1. Okay, if we fix this also, then total number of permutation is n minus 2, say similar to last. So this is what, this is the n minus 1 factorial. Okay, this is n minus 1 factorial. So how many number of permutations? The permutations, total number of permutations is n minus 1 factorial. Okay, but this permutation we can find if and only if the current, if and only if the minimum value lies on the 0th index. Okay, so this is how this question will be solved. Okay, now the coding part is very easy, so I will show you the part code of my which is I write here. Okay, I will show here. Okay, initially I take the modulo m. Okay, because the answer may be large, so that's why I take modulo m, and complexity, length, and the count 1 for finding possible permutation. Okay, permutations, and here the most important condition is the, if the complexity of 0th index is greater than the other complexity of ith index. Means if the complexity at ith computer, if the ith computer have lesser complexity than the complexity at 0th computer, then return 0, because we didn't decrypt all the computers. Okay, and if this condition is not true, then we find the, then we have to try to find the possibility. Okay, and don't forget to take modulo. Now let's run it. Okay, test cases are passed. Now submit it. Okay, it's submitted. Okay, if you have any doubt, then please comment in the comment box. Okay, thank you.